Hello, everyone. I hope you're all healthy and doing well and enjoying this time at home. This video is just to give you a few notes on reaction rates. So I want you to go to page 88 in your notes, and you can just take notes along with me as I write stuff down. I don't have my actual notes here, so I'm just using a piece of paper, but hopefully you have your actual notebook with you. So before we start writing stuff down, I just want to review the stuff that we wrote down on page 87. So on page 87, you should have something about this thing called collision theory, which you remember tells us that if a reaction occurs, we have to have three things happen. For a reaction to happen, you have to have molecules actually hit each other, so they actually have to collide. They have to have enough energy, and they have to be like facing the right direction. That's what we mean by the correct orientation. So we want to remember those three things as we're thinking about reaction rates. So we're going to write down 4 ways that you can make a reaction happen faster. So we're going to put ways to increase reaction rate. And you all tested a bunch of these in the lab the other day with the yeast catalase lab, that turned out really well. Your conclusions were really good on that, by the way, so good job. One of the things that we didn't actually test in that lab is surface area. So one of the ways that you can make a reaction happen faster is by increasing the surface area. Now, let me explain what I mean by increasing surface area. So let's say you're trying to burn sugar. Do you think the sugar would burn more easily in like sugar cube form or as powdered sugar? And if you're not sure, the answer is powdered sugar. So powdered sugar is more spread out. It has more surface area. So when we talk about increasing surface area, we're really just talking about breaking particles or breaking substances up into smaller pieces. So if you throw a bunch of sugar cubes up in the air, that's not really a fire hazard. That's not likely to burn. But if you throw a bunch of powdered sugar or any other like fine-grained particles into the air, that can actually be a fire hazard, and it can cause something called a dust explosion because you have increased the surface area. So again, increasing the surface area is done by creating smaller particles. Now, the reason that increasing the surface area increases the reaction rate is that if the particles are more spread out and there's more of them, then you're going to have more collisions. So we're going to explain why all of these increase the reaction rate, and increasing the surface area causes more collisions. So we want to be able to explain all of these effects in terms of collision theory. Okay, the next thing that can increase the reaction rate, which some of you did test in the lab, is increasing the concentration of the reactants. So some of you tested different concentrations of hydrogen peroxide, and you probably found that the greater the concentration of hydrogen peroxide, the faster the reaction. And again, that's going to be because when you increase the concentration, there are going to be more collisions. Okay, so that's a pretty easy one. Another thing that some of you guys tested was temperature. So if you increase the temperature, your molecules or atoms are going to be moving around more quickly, and so they're going to collide more often, and those collisions are going to have more energy. So more collisions with greater energy. That is going to give you a greater reaction rate. Okay, the last thing that we want to talk about that can increase reaction rate is adding a catalyst. So a catalyst, we'll just write this down first, adding a catalyst. So a catalyst speeds up the reaction without being used or consumed. So in your lab, the catalyst was the catalase, and it did not get used up. There was still the same amount of catalase at the end as there was at the beginning, and that's the definition of a catalyst. It doesn't get used up in the reaction, it just helps it happen faster. People will often use the analogy of a matchmaker. So a catalyst is kind of like a matchmaker for a reaction. Catalysts often literally take the two reactants and like hold them together. So enzymes sometimes will allow the two reactants to bind, and then they will like put them in the right orientation so that they can react. So you can think of catalysts like matchmakers. And if we were in class, I would have showed you this picture from The Princess Bride to represent a matchmaker. Couple things you want to know about catalysts. Catalysts lower the activation energy. And if you remember from page 87, the activation energy is the energy you need to start a reaction. So a catalyst takes that energy and decreases it. So last thing we're going to write down here is we're going to draw a little graph. And on the y-axis, we're going to label potential energy. And on the x-axis, we're going to label it reaction progress, which is kind of a weird label, but you'll kind of see how this works in a second. So for this graph, we're going to draw kind of like a straight line, and then we're going to draw a hill, and then we're going to make it go all the way down here. And we're going to label this first part of the graph as the reactants, and this last part as the products. So if you haven't ever learned this, the reactants are what start the reaction. They're the two molecules that exist at the beginning of the reaction. The products are the molecules that are formed in the reaction. So this is the beginning part of the reaction, the end part of the reaction. And you might guess that this hill represents the activation energy. And you can see it is pretty high. These reactants have to get over this big hill before they can react and turn into these products. But if we add a catalyst, it lowers the activation energy. So I'm going to draw a similar curve but with a dotted line. And this represents the activation energy with a catalyst. So you can see it's a lot lower. All right, and those are the main things that you guys need to understand about reaction rates and how you can make reactions go faster. Now, some of you might wonder why we didn't talk about pH. Some of you tested pH and you found that the pH did affect the reaction rate. And like, these are not the only things that affect reaction rate. There's other things, but these are just the four that generally people tend to focus on, that textbooks focus on. So there's always more stuff to learn in chemistry. So pH does affect reaction rate, like you guys found out in the lab. So after this, there's another little video that you can watch that kind of gives you a nice analogy for some of these things that affect reaction rate. And then there's just a little homework assignment with some questions. We're keeping it pretty easy and simple today. And then we're going to learn some more intense stuff on Tuesday. Will be the next time we work on this class. So I hope you guys have a good time at home and that you have a good weekend. And hopefully we'll see you soon.